This is 2.2a, part 2. We're continuing on with our exponent properties. We know that 2 to the third power, 2 times 2 times 2, is 8. We know that 2 squared is 4, and we know that 2 to the first is 2. By comparing these, if we were going to decrease the exponent by 1, from 3 to 2 to 1, we would divide the number by 2. 8 divided by 2 is 4, divided by 2 is 2. If I was going to continue this trend to decrease the exponent by 1, that would suggest that 2 to the 0 is 2 divided by 2 equals 1. And that suggests the zero exponent property. X to the 0 power is 1 for any non-zero x. Okay? Therefore, 7 to the 0 is 1. Any quantity to the 0 is 1. So whether it's a number or several different values to a quantity, if it's raised to the 0 power, it's 1. Okay. Any quantity to the 0 power is 1. So this is going to be 2 times 1, which is 2. The 2 not in the parenthesis is not affected by the 0 power property. Okay. Continuing that previous pattern, we know that so 2 squared is 4, 2 to the first is 2, 2 to the 0 is 1. Again, the same pattern says that as you decrease the power by 1, you're dividing by 2, dividing by 2. This suggests that if you decrease the power 1 further to -1, you need to divide by 2 again, and so you would get 1 divided by 2, 1/2. 2 to the -1 is 1/2. This suggests the negative exponent property. X to the -1 is the fraction 1 over x. So, 7 to the -1 is 1/7. 3xy to the -1 is 1 over 3xy squared. 3xy squared to the -1 is 1 over 3xy squared. And in part C, I want to make sure that I observe that the -1 power is not on everything. It's just on x, and then again, just on y. So the 7 is going to stay where it is. So if I have my 7 here, that x is going to move to 1 over x, which will put it in the denominator. The y would move to 1 over y in the denominator, but if I'm dividing by a fraction, it's going to flip, right? It's going to be the reciprocal. Instead of 1 over y in the denominator, it's going to flip to y over 1. So the result is going to be that the x to the -1 moves to the denominator from the top, and the y to the -1 moves to the numerator from the bottom. The result is 7y over x. That's going to lead us to our next property. For non-zero x, x to the -n is 1 over x to the nth power, and 1 over x to the -n is going to be x to the n over 1. So, just as a summary, if it is in the numerator already, it's going to move to the denominator. If it's in the denominator already, a negative exponent is going to move it to the numerator. Doesn't matter if the power is -1 or -2 or -3. The n value doesn't matter. It's the negative that causes the movement of the base. Let's look at a few examples. If I have 8 to the -2, that's going to be the same thing as 1 over 8 squared. And then since 8 is numeric, I can do 8 squared, so we get the fraction 1 over 64. If I have 3 to the -3, that negative power is going to move that to the denominator, and 4 to the -2, that's going to move that to the numerator. So I'm going to get 4 to the +2 over 3 to the +3. Once a base value moves, the exponent changes sign, so the negative becomes positive. Then you can simplify. You can do 4 squared is 16 over 3 cubed is 27. Okay. If you're curious, you can check this on your calculator by checking 3 to the negative 3 divided by 4 to the negative 2. And if you use your math button to convert this to a fraction, you'll see that you do get the fraction 16 over 27. So just as a way of verifying your answer. That is what it should come out to be. Okay. In example 11, we're going to simplify. We're going to have some mixed practice here. So I want to simplify by moving only things that have negative powers. So the only item in example 11 part A that has negative power is the x. 2 does not, y does not. So the 2 and the y cubed will stay where they are in the numerator, and x to the positive fifth will move to the denominator. That's going to be simplified. An expression is going to be considered simplified once it has only whole numbers for exponents. In part B, 8x to the negative 13th, the negative 13th power is just on the x, so the 8 is going to stay in the numerator, and x to the positive 13 will drop into the denominator. Okay. In the next one, I've got 2 to the negative third. That's going to have to go to the denominator. X to the fourth can stay where it is, but x to the negative 7th will move into the denominator. So x to the fourth over 2 to the third, x to the 7th. This isn't finished because of two things. First of all, x to the 7th and x to the fourth can reduce, leaving the larger number of x's in the denominator, and 2 to the third can reduce. So I would subtract. My numerator is going to be empty, 1 over x to the fourth, x to the 7th, the larger one, x to the 7th, minus x to the fourth gives me x to the third in the denominator, and I know that 2 cubed is 8. So when I subtract the exponents, I always look for which one's larger because the base, x, is going to land in the position that has larger. Think about it this way. 4 of these cancel with 4 of those, leaving 3 in the denominator. All right, in number 6, before I get to moving things, we're going to distribute our power. So we're going to have 6 to the negative 2 times x to the negative 3 times negative 2 is going to be positive 6. Now I only have a negative power on 6, so the x to the 6 will stay in the numerator. 6 squared will move into the denominator, and because 6 squared is numeric, we'll calculate it x to the 6th over 36. One page left of examples. Example 12. Now, I've got a fraction here. I look at my numbers first, and I can reduce 21 and 7, both by 7. That's going to give us 3 and 1. Then, before I simplify the m's or the n's, I like to move my negative values because it's easier for me to work with positive values than to work with negative values. So I'm going to simplify and say this is 3. M to the third, I'm going to move n to the fifth also into the numerator over 1. I don't need to write the 1. I'm going to have n to the third in the denominator. I'm also going to have n squared in the denominator. Then I can follow the rules to add up the same bases. If I multiply them together, I add up the powers of the same bases. So I'm going to end up with 3m to the 3 plus 5, so 8th, over n to the 3 plus 2, so 5th. There's more than one way to get this answer. You could subtract first or you could move first. I prefer to move my negatives first. All right. Now in part B, because there's a lot of different negatives going on right here, what I would do first is distribute the power so that I'm not moving twice, because some of these negatives are going to cancel out. So for example, x to the negative 2 to the negative 3, 2 negatives are going to make the x to the positive 6th. Y to the negative 3 and negative 3 makes that y to the positive 9th. And x to the negative 4, negative 3, it's going to be x to the positive 12th. And y to the negative 2, negative 3, so y to the positive 6. So they actually all came out positive once I did the multiplication. Now I reduce. The larger number of x's are in the denominator. So when I do 12 minus 6, it's going to land me with x to the 6 in the denominator. The largest number of y's are in the numerator. So when I do 9 minus 6 is 3, it's going to leave me with y to the third in the numerator. 2 left. Here I have to do my distributes first because I have a separate distribute in the numerator and the denominator. There are 3 parts in the numerator and 3 parts in the denominator. It's going to give me 2 to the negative third, x to the negative negative, so positive 12th, and y to the negative third, over 4 squared, x, 2 times 2, so 4, and y to the negative 10th. Okay, so the next thing I would do is move the pieces that have negative exponents, leave the pieces that have positive exponents. So my numerator is going to stay x to the 12th, then times y to the 10th. My denominator is going to have 4 squared, which you can just go ahead and say is 16, times 2 to the positive third, x to the 4th, and then y to the 3rd is going to jump down and join it. Okay. Finishing the x's, there are 12 in the top minus the 4 in the denominator. That's going to leave me with x to the 8th in the numerator. The y's, 10 in the top, 3 in the bottom. That's going to leave me with y to the 7th in the numerator. Then my numbers are going to be 16 times 8, since 2 cubed is 8, and I just need to finish that multiplication to get the numeric value. So I have x to the 8th, y to the 7th, over, and you can just do a quick calculation. 16 times 8 is 128 in the denominator. Last one. Okay, so each of these is separate. There's no power on everything. So I can begin by moving things that have negative powers. So I'm going to move the a squared to the bottom. I'm going to move the b to the 5th to the bottom. I'm going to move the b to the 1st to the top. I'm going to move both the a to the 7th and the b to the negative 2nd to the top. While I'm at this, I'm also going to reduce my numbers to save time. So I can also reduce any numerator number with any denominator number. So I'm going to reduce my 16 and my 8. 8 goes into 16 twice. It's going to leave me 2 over 1. And I'm also going to reduce 15 and 25 both by 5. That's going to leave me with 5 in the numerator and 3 in the denominator. So numbers first. 2 times 5 is 10 for the number. 3 times 1 is 3 for the number. Then let's write all the values that we're going to have left on the top. We're going to have the a to the 4th and the b that were already in the top. Now joining them are going to be a b, an a to the 7th, and a b squared from the denominator. Those come up. Letters in the denominator, we already had an a to the 5th. That's it. Joining it, it's going to be an a to the 2nd and a b to the 5th. The numbers 10 third stay the same. Combine your numerator, a to the 5th, a to the 4th, a to the 7th. 4 plus 7 is 11. A to the 11th. I've got b, b, and b to the 2nd. So 1, 2, 3, 4. So b to the 4th. In the bottom, a to the 5th, a to the 2nd. That's a to the 7th. And b to the 5th. Once more, just to reduce. So 10 thirds, a to the 11th over a to the 7th. 11 minus 7 stays in the top because that was a larger value. 11 minus 7 is 4, so a to the 4th. B to the 4th, b to the 5th, the large number in the denominator. 5 minus 4 is 1 left in the denominator. This is going to end up as 10 thirds, a to the 4th, b. That is the end of part A.